Welcome to qnawire.
So we're told that we have an individual that drives a distance 3.25 kilometers north. And so I'm converting north, east, south, and west cardinal directions into an X and Y axis grid. So I drew out our cardinal directions, northeast, southwest. And then I'm going to write here in red the directions of X and Y, right? So north is positive Y, south is negative Y, east is positive X, west is negative X. Okay, so then if we have somebody that drives 3.25 kilometers straight north, they're traveling at an angle relative to the x-axis, which I call angle A, of 90 degrees. We're then told that the individual drives straight west a distance of 2.9 kilometers. So the next vector, vector B, is 2.9 kilometers, and the angle it travels relative to the x-axis, since it's traveling straight west, it's traveling to the negative x-axis, which is an angle theta of 180 degrees if the positive x-axis is 0 degrees. And then vector C, we're told they drive straight south then. So vector C, which is 1.5 kilometers, is an angle of negative 90 degrees relative to the x-axis, since it's straight south, but negative 90 degrees is also the same as 270 degrees. So theta C is negative 90 or 270, whichever you prefer to use. So then to find the displacement vector's magnitude D and the angle D, we need to use A, B, and C. Okay, so displacement vector D is going to be equal to the components of the x components of vector A, B, and C added to the y components of vector A, B, and C, but we have to keep them separate, right? So we have the x component of A plus the x component of B plus the x component of C, all added together to form the x component of D, which we're going to call the I hat direction, right? I hat, x hat, same thing. These are vectors. So we also need to add all the like y components. So this would be A of y plus B of y plus C of y in the j hat direction. But we can simplify this just a little bit before we start doing calculations. First thing we can do is we notice that A of x and C of x both have to be 0 because vector A and vector C are traveling in the north-south direction or in the y plane only. There's no travel in the x plane for vector A and vector C. So those are both 0. And then we can do something similar for the other one, right? A and y again, or A and C again are only traveling in the y direction, in the north-south direction. But B travels only in the x direction, in the east-west direction. In fact, it's going directly west. So B has no y component, so we can get rid of B of y. Okay. Now, B of x is just going to be the magnitude of vector B times the cosine of the angle theta B. You could immediately recognize that the cosine of theta B is just going to be -1, since it's 180 degrees. Cosine of 180 degrees is -1. We also know it's traveling straight west, which is the -8x direction. So it's going to be the magnitude of vector B, but negative. But let's go ahead and be explicit and write it out like that. Because if it was a different angle that wasn't a nice angle of 0, 90, 180, 270, there would be a little more nuance there. So let's make sure we're accounting for that. So then A of y would be A times the sine of the angle theta A. And C of y is just going to be C times the sine of the angle theta C. And those are our j hat components, or our y components of D, vector D, the displacement vector. So B times the cosine of the angle theta B is just going to be the negative magnitude, which was 2.9 of vector B. And this is kilometers in the I hat direction, plus A times sine of theta A is just the magnitude of A, so that's 3.25. And then C times the sine of the angle theta C is just going to be -1.5, because theta C is going to give you a -1 value times the magnitude of C. So we have 3.25 minus 1.5, or 1.75 kilometers. And that's your j hat. So now we have our I hat and j hat components of vector D, so we can use Pythagorean theorem to find the magnitude of vector D. is just going to be equal to the square root of the sum of the squares that make up both sides. So this is going to be negative 2.9 kilometers squared plus 1.75 kilometers squared, all square rooted. So that gives us units of kilometers in the end. So we can pull that out front. Plugging those values in, taking the square root, we find that this is equal to 3.39 kilometers. Okay. And then to find our angle, we need to find the angle that is made from that right triangle that makes up vector D from the two sides, 2.9 in the I hat, or negative 2.9 in the I hat, and 1.75 in the J hat. And we can use our trigonometric identity, which says that alpha, or the tangent of the angle alpha, is going to be equal to the opposite over the adjacent, or 1.75 over 2.9. So therefore, actually, let's start a new page here. Therefore, alpha is going to be equal to the inverse tangent of the opposite over the adjacent, which is 1.75 over 2.9. But the 2.9 is negative. So this gives you negative 31.1 degrees. Okay, so just a quick sketch here. What we're dealing with here is we have this displacement vector. So we go, let's draw it in red. We go north, right? Then we go east, or we go west, then we go a little bit south. So we're about here. Our displacement vector, I'll draw it in blue, would be from our origin to that new point here. So there's D. The angle we just found was this angle here. Here's alpha. Okay, and it's negative then because it's coming up off of that x-axis. What we really want is I'll draw this in green, we really want this angle here. We'll call this theta, the angle relative to the positive x-axis. So then theta is equal to 180 degrees plus alpha. Alpha is negative 31.1, so 180 degrees minus 31.1 is 148.9 degrees, which makes sense that it's a little bit less than 180. You can see in that diagram that we would expect that to be true. Okay, so now it wants us to draw out the diagram more explicitly than we just did there to show why the value for the displacement vector of 3.39 kilometers and the angle that we just found makes sense. So let's start one more new page. We can draw this out. Actually, let's do it right in the middle so we have plenty of room. Right? So I'll do it again in red. So the first thing we did was we traveled 2.9 kilometers straight, so first thing we did was travel 3.25 kilometers straight north, right? So that was our vector A, straight north. Then the next thing we did was we traveled 2.9 kilometers straight west. West is this direction, so we go 2.9 kilometers that way. That would be vector B. Then the last thing we did was travel 1.75 or 1.5 kilometers straight south. So now we travel 1.5 kilometers this direction. So there's vector C. Our resulting displacement vector then would be this vector here, vector D. And it is in the third quadrant as our angle predicted. If A there is equal to 3.25, it makes sense that and B there is equal to negative, or is equal to 2.9. It makes sense that D is about 3.39. That seems to be about right. Okay. So then also we found this angle here, this angle theta. And we said theta was 148.9 degrees. That makes sense. That looks like about 138.9 degrees. We also found this angle here, alpha. And we found that that was equal to 31.1 degrees. That does look about 31.1 degrees. So indeed, our answer makes perfect sense.